Few natural phenomena command as much awe and terror as a tornado. And among these destructive forces, one stands paramount: the F5 tornado, now categorized as an EF5 on the enhanced Fujita scale. These are nature's most violent storms, packing wind speeds that can exceed 200 miles per hour. Their raw power is capable of leveling reinforced concrete structures and scouring pavement from the ground. In this script, we explore the immense destructive capability of an F5 tornado, understanding how they form, their historical impact, and why their study remains crucial. To understand an F5 tornado, we first need to understand tornadoes in general. A tornado is a rapidly rotating column of air extending from a thunderstorm to the ground. Most tornadoes form from supercells, which are powerful thunderstorms characterized by a deep, persistent rotating updraft called a mesocyclone. The conditions necessary for supercell and subsequent tornado formation are specific. First, you need warm, moist air near the ground. This provides fuel for the storm. Second, cooler, dry air higher in the atmosphere. This creates instability. Third, wind shear. This is a change in wind speed and direction with height. Wind shear is crucial. It causes the horizontal rotation of air, which can then be tilted vertically by the storm's updraft, forming the mesocyclone. Once a mesocyclone is established, a rotating column of air can extend down from the storm cloud. If it reaches the ground, it becomes a tornado. The Fujita scale, developed by Dr. Tetsuya Theodore Fujita, rated tornadoes based on the damage they caused. It ranged from F0, light damage, to F5, incredible damage. The enhanced Fujita scale, EF5, was implemented in 2007 to better align damage with estimated wind speeds, but the EF5 rating retains the legacy of its F5 predecessor. An F5 or EF5 tornado represents the absolute pinnacle of this destructive potential. Wind speeds in these tornadoes are estimated to be over 200 miles per hour, potentially reaching 300 miles per hour or more. The pressure drop within the funnel can be significant, contributing to the explosive damage observed. Their paths can be miles wide and dozens of miles long, leaving a swath of total destruction. True F5 EF5 tornadoes are rare, thankfully, but when they do occur, their impact is catastrophic and unforgettable. One of the most infamous F5 tornadoes was part of the super outbreak of April 3-4, 1974. This outbreak saw 14 F5 tornadoes rip across 13 U.S. states and one Canadian province in just 18 hours. Among them were at least 6 F5 tornadoes. One particularly devastating F5 struck Xenia, Ohio. The tornado caused extensive damage to the city, including its high school, many businesses, and residential areas. It killed 34 people and injured 1,150. The damage was so severe that entire neighborhoods were leveled, with houses reduced to mere foundations. Another harrowing example is the Moore, Oklahoma EF5 tornado of May 20, 2013. This tornado was on the ground for 39 minutes, traveling 17 miles. It reached a maximum width of 1.1 miles. The Moore tornado caused immense damage, particularly to 2 elementary schools, Plaza Towers and Briarwood, and the local hospital, Moore Medical Center. It resulted in 24 fatalities and 212 injuries. The damage included entire blocks of homes completely swept away, leaving only bare concrete slabs. Vehicles were tossed hundreds of yards, and infrastructure was severely compromised. The Tri-State tornado of March 18, 1925 stands as America's deadliest tornado. Though the Fujita scale wasn't established then, based on the catastrophic damage, it's retrospectively estimated to be an F5. This single tornado traveled 219 miles through Missouri, Illinois, and Indiana, killing 695 people and injuring over 2,000. It moved at an average speed of 62 miles per hour, giving communities little to no warning. Entire towns were essentially wiped off the map. Its sheer size and rapid forward speed contributed to the unprecedented death toll. These examples highlight common characteristics of F5 EF5 damage. Total destruction. Well-built frame houses are completely swept away, leaving only foundations. Debunking misconceptions. Sometimes pavement is scoured from roads. Large objects like cars can be thrown incredible distances. Widespread impact. Their path often encompasses many square miles, affecting multiple communities. The study of F5 EF5 tornadoes matters profoundly for several reasons. Primarily, it drives advancements in meteorology and early warning systems. The ability to predict and track these storms saves lives. The National Weather Service, for instance, uses Doppler radar and a network of trained spotters to issue tornado watches and warnings. A watch means conditions are favorable for tornadoes, while a warning means a tornado has been sighted or indicated by radar. Understanding the mechanics of these most powerful tornadoes helps scientists refine predictive models. This includes better identifying the specific atmospheric ingredients that lead to such extreme rotation and intensity. Every bit of knowledge gained helps improve lead times for warnings, giving people more crucial minutes to seek shelter. Furthermore, studying F5 EF5 damage patterns informs better construction practices. Engineers learn which building materials and structural designs can withstand extreme winds, leading to stronger building codes in tornado-prone regions. Community preparedness is also vital. This includes developing robust emergency plans, establishing accessible storm shelters, and educating the public on safety protocols during a tornado event. This collective knowledge reduces fatalities and injuries even in the face of nature's most extreme forces. The F5 tornado, or its modern equivalent EF5, stands as a testament to the raw, untamed power of the Earth's atmosphere. These rare, incredibly violent storms remind us of our vulnerability to nature's most extreme forces. Yet, through dedicated scientific research, advanced warning systems, and community preparedness, we continue to improve our ability to face these threats. Understanding the raw power of an F5 tornado isn't just about documenting destruction. It's about learning, adapting, and ultimately saving lives.